Okay, in this section we're going to talk about in this lesson arithmetic sequences and series. An arithmetic sequence is just a sequence of numbers that have a common difference between consecutive elements. There's all kinds of sequences, and there are lots of different types of sequences, but if you want to call it a arithmetic sequence, then it has to have a common difference, which means the difference always has to be the same. So for example, the most basic sequence, arithmetic sequence, is just the natural numbers. And that can go on forever or to infinity. That's called an infinite sequence. A finite sequence would be a sequence like this. Let's say the odd numbers all the way to 100. That would be a finite sequence. There's a specific number of them. It's an arithmetic sequence because they're all separated by 2, and so it's the even numbers, not odd numbers, the even numbers from 2 to 100. That would be considered a finite arithmetic sequence. Arithmetic sequence can be huge numbers, separated by 1,000 all the way up to 100 million or something. That would be considered a arithmetic sequence, just using much bigger numbers. So those are different types of arithmetic sequences. So we want to be able to do things with these arithmetic sequences. First, let's understand an algebraic representation. An algebraic representation often is going to have two parts. It's going to have the first part we're going to call the starting point. Okay, our starting point is going to be wherever basically what your first number is, and then we're going to add to that a second part, which is going to be the difference. Or, if you want to really understand it algebraically, it's going to be the rate of change. This is actually going to form what we would call a linear function. So, for instance, if we look at those even numbers, it would look like this. 2 is our first number, plus each one is divided by 2 times some integer, where x is an integer. Well, in this case, it's actually a natural number. Right? If you wanted to find 2, actually I would have to say a whole number, not a natural number, because the way this is written, the x is going to be 0, because you're going to have 2 plus 0. Then you add 1 to it, so you're going to get 2 plus 2, which gives you 4. When x is 2, you get 2 plus 4, which would be 6. When x is 3, you get 2 plus 6, which would be 8, and so on and so forth. So one of the questions is, what is x in this case when you need 100? Well, x is going to be, 100 minus 2 is 98. 2 divided by 98 is 49. And so x is 49. But if you notice, you went from 0 to 49, so there are actually 50 terms in this sequence. So that leads us to understand if we have, for instance, in this one, it says, what is the 24th term of this sequence? Well, if we write it algebraically, this would be 2 is the starting point. 3 is the difference times some integer. But if we wanted the 50th term up here, didn't we actually need to multiply by 49 instead of 50? So if I wanted the 24th term, I just do 2, the starting point, times 3, or plus 3 times 23. So the 24th term is 69 plus 2, which is 71. Another way to do this, if I gave you that it ended at 71 and said, what term is 71? You do 2 plus 3x equals 71. Use your algebraic representation. Subtract 2, divide by 3, and you get 23. And so it would not be the 23rd term, though. It's the 24th term, because you always have to add 1, because whenever we use this algebraic representation, we start at 0 instead of 1. So another example is how many terms are in the sequence. So we use our algebraic representation. 11 is our starting point. Common difference is 7. So we do 11 plus 7x. That equals 116. So what is x when that's going to happen? Subtract 11, you get 7x equals 105. so x equals 15, but we always have to add 1, so the 116 is the 16th term in that sequence. This one is a little bit different. Example 3, what is the 35th term in the sequence? Well, this time your starting point's 19, but instead of being a positive arithmetic sequence, it's a negative arithmetic sequence. So we're actually adding -6 each time. So what's the 35th term in the sequence? Well, we don't multiply by 35, we multiply by 34. And so we do -6 times 34, which actually equals -206. So -206 plus 19 equals a negative, and then it's going to be 187. So -187 is the 35th term in that sequence. But again, we can just use this algebraic representation to help us understand it. Okay, an arithmetic